So scientists believe that during this period, what would have happened in the initial days of the formation of Earth, there would have been like this formation of clouds. Earth would have been covered almost with clouds. That our atmosphere has been formed as a result of a phenomena which we call it as the phenomena of degassing. Remember, before this was known, our scientists used to believe that the atmosphere was actually formed from some kind of meteorite which impacted the earth and atmosphere came with that meteorite. But today several experiments, in fact the study of volcanoes has clearly told us that it was not so, and it was our present atmosphere that we are talking about. It was essentially result of the phenomena of degassing. However, one more question arises to us. We know that there are several planets in the atmosphere, like for example Jupiter, Saturn, and many of them are actually far away from the sun. Now, since they are being far away from the sun, clearly their temperature is what it is comparatively lower. And we find that there is a very dense atmosphere that is present in them. The planets which are near to the sun, you can understand, because of the very high temperatures and other factors, I'll talk about them. What could have happened? The atmosphere would have escaped. It would have gained that escape velocity and it would have been lost in the space. But many of these planets are big, they have higher gravity, and they are also away from the sun. So they retain their original atmosphere. And when we study their atmosphere, what we find that their atmosphere is very drastically different from that of the earth. It is contained of many gases, like for example nitrogenous or gases like methane, etc. Several such kind of gases are contained in them which are very, very poisonous, where life is not possible. So question arises that the present earth's atmosphere, we know that it is very unique. So how it became unique? Was the atmosphere before on the earth similar to those planets and later it changed, or from the beginning the atmosphere of the earth was like this? Answer to these questions is very clear, that if we talk about the present atmosphere that we are having, scientists call this present atmosphere as the tertiary atmosphere. They are calling it as the tertiary atmosphere. That means that before there has been at least two atmosphere before this tertiary atmosphere. That means before this there was primary atmosphere, then there was secondary atmosphere, then came the tertiary atmosphere. In fact, you know, today as I showed you the carbon dioxide increase, one thing is very clear. We are calling this era when human beings are becoming dominant species as the Anthropocene. And in this Anthropocene, we human beings are changing the environment at very rapid rate. And one of the environmental component which has been changed by us is the atmosphere. So some scientists are saying that today, in fact, this tertiary atmosphere is also changing into a Quaternary atmosphere. Quaternary atmosphere. So can you understand that even before this there were several atmospheres? So let us see how this evolution of the atmosphere would have occurred. So we find that our earth was at the beginning, our earth was very hot, and scientists believe that it was either in gaseous form, which you must have studied in your NCERT maybe. It was referred to as nebula, or some also believe that actually it was liquid in nature. Whatever be the case of the earth, it was very, very hot. One thing is clear, when a very hot object is present, you can understand the loss of energy from this object would be most rapid from the surface. So this hot gaseous or liquid, whatever it was cooling down fast. And where the fastest cooling was taking place? On the surface. Now, because of this, you can very clearly understand that there would have been formation of a thin crust under which the heat of the earth would have been trapped. Now, clearly, still there was a very thin atmosphere present here. Atmosphere would have been present, a thin atmosphere would have been present here surrounding the earth. And if you talk about this thin atmosphere, what we know, this is what we are calling it as the primary atmosphere. And scientists believe that this primary atmosphere was similar to what we find today on the planets like Saturn, Jupiter. So it was similar to those kind of planets. Question arises, what happened to our primary atmosphere? Now, the answer lies in number of facts. One important fact is that if we look into our Earth, Earth is inner planet. You must be aware, the planets which are near to Sun up to Mars are referred to as the inner planets. Outside that belt is the outer planets. So one, it is an inner planet. Characteristic of inner planets is one, they are smaller in size. Second characteristic is that these inner planets are near to the Sun. Near to Sun. So smaller size means smaller gravity. And near to Sun clearly means greater temperature. Also, its own temperature of the earth was very clearly, you can understand, it was very high. So, very light gases which formed the atmosphere of the earth at that time, nitrogen, hydrogen, helium, these gases, scientists believe they escaped into space and were lost. Okay, so because of these factors and the own high temperature, ultimately, so added with this was the own high temperature of the earth. So because of these factors, what happened? The primary atmosphere was lost in the space. Now the question arises, then how the atmosphere that is present, it came into being if it was lost? So answer lies in what we were talking about before. As the earth was cooling down, you can understand that as the earth was cooling down, the cooling was fastest, most rapid from the surface. And this faster rapid cooling led to what? Formation of a thin crust. Now you all must be aware that crust is made up of rocks. And rocks are poor conductor of heat. So that means there was lots of heat which was trapped inside the earth. Now you know the law of nature, anything which is hot, it would try to cool down, but there was an impediment. The crust was an impediment made up of rocks which are poor conductor of heat. So one way the earth could have cooled down was if there was fractures in this crust at several places, then there was a possibility that the earth could have cooled down. Clearly you can understand that as these fractures would have taken place, there would have been molten material referred to as magma which reaches the surface and is referred to as lava would have come out of these fractures. You know that we call these fractures or openings in the crust as volcanoes, from where hot interior rocks or lava is coming. And studies have proven that when there is volcanism phenomena, along with volcanism there is a phenomena which we call it as degassing. Degassing. That means lots of gases also come out during the process of volcanism. Several studies have shown that the most important gas which comes out is water vapor, which can be as high as up to 70% of the total gas is coming out. Besides, there are others like, for example, carbon dioxide, there is nitrogen, and there are several other inert gases, also some sulfur compound, etc. These are coming out during the process of degassing. So, scientists believe that it is the process of degassing which ultimately led to the formation of our secondary atmosphere. Secondary atmosphere. So, in this manner, secondary atmosphere would have been formed, and these would have been the major component of this secondary atmosphere. If we compare the composition of the secondary atmosphere with our present atmosphere, we find that our present atmosphere is very, very different. So, how this very different atmosphere has come into being? How it is it entirely a new atmosphere, or was this atmosphere modified? We will see that this secondary atmosphere was actually modified by several physical and biological processes to give rise to our contemporary atmosphere, which we call it as the tertiary atmosphere. And what are these processes? You can understand number of processes would have been formed. For example, let us take one physical process. We know that if lots of water vapor is present, what will happen? This water vapor will rise and it would cool down, and cooling down of this water vapor would lead to formation of clouds. So, scientists believe that during this period, what would have happened in the initial days of the formation of Earth, there would have been like this formation of clouds. Earth would have been covered almost with clouds, and there would have been very heavy precipitation which would have occurred from these clouds. At this point, Earth was although cooling down but still quite hot. So, what happened? Even before this precipitation could reach the surface, it would again re-evaporate and become clouds. So, the process continued. This also helped the cooling of the Earth's surface. Ultimately, the raindrops would have fallen down. Scientists believe that these ultimately make up our oceans which are present today. So, that means much of the water vapor which was added into the atmosphere, this water vapor ultimately became our oceans. So, that explains why there is less amount of water vapor today present in the atmosphere. But what happened to carbon dioxide? We know, we just now saw that carbon dioxide is very, very less. It is just 380 ppm. It has increased because of human activity. Before, if we see, it was less than 280 ppm. So, why so much less of carbon dioxide? Here we can see carbon dioxide. In fact, several studies prove that almost during degassing 15% is carbon dioxide. So, how this much less carbon dioxide? Answer lies in the fact that if we look into the atmospheric carbon dioxide, during the process of precipitation, you must be aware that this carbon dioxide gets dissolved in the rain droplets, and ultimately it would fall down with the rain droplets. And if we today actually measure the amount of carbon dioxide present in the oceans, what we find that oceans have 60 times more carbon dioxide than the atmosphere. So, very clearly, much of carbon dioxide would have been removed from the atmosphere because of this process. But this still it doesn't explain why so much less carbon dioxide. Much of it would have been removed, but still it should have been more. And it doesn't explain how oxygen, you can see there is hardly any oxygen during the process of degassing. How oxygen became the second most important gas. We can understand that in the degassing, nitrogen is almost 5% in composition. So, nitrogen can become, if carbon dioxide, much of it is removed, then nitrogen will become the most important gas. That is for sure. But how oxygen came into being? The answer lies in the fact that ultimately at some point of time there would have been evolution of life, and through this evolution of life there would have been formation of green plants who perform this process of photosynthesis. And you know, through the process of photosynthesis, what is being done? There is absorption of CO2, and what is oxygen is coming out, or oxygen is formed through the process of photosynthesis. So this also explains how rest of the carbon dioxide would have been removed from the atmosphere, and how oxygen became the second most dominant gas in the atmosphere. Okay, so that is basically how we find the present atmosphere came into being.